10. How existential-out differs from the other rules. As stated in the previous section, although we annotate existential-out just like other elimination rules like etc., it is not a true inference rule, but is rather an assumption rule. In the present section, we show exactly how O is different from the other rules in predicate and sentential logic. First, consider a simple application of the rule O. XFX. Flaw. This is a valid argument of predicate logic, and the corresponding derivation is trivial. 1 XFX PR2 flaw DD3 flaw 2, O. Next, consider a simple application of the rule I. Flaw. XFX. Again, the argument is valid, and the derivation is trivial. 1 flaw prairie 2 XFX DD3 XFX1, I. The same can be said for every inference rule of predicate logic and sentential logic. Specifically, every inference rule corresponds to a valid argument. In each case we derive the conclusion simply by appealing to the rule in question. But what about O? Does it correspond to a valid argument? Earlier, I mentioned that, although the notation makes it look like O, it is not really an inference rule, but is rather an assumption rule, much like the assumption rules associated with CD and ID. Why is it not a true inference rule? The answer is that it does not correspond to a valid argument in predicate logic. The argument form is the following. XFX. Flaw. In English, this reads as follows. Something is F, therefore, A is F. That this argument form is invalid is seen by observing the following counterexample. 1. Someone is a pacifist. 2. Therefore, Adolf Hitler is a pacifist. If one has XFX, one is entitled to assume flaw so long as A is new. So, we can assume for the sake of argument that Hitler is a pacifist, but we surely cannot deduce the false conclusion that Hitler was a pacifist from the true premise that at least one person is a pacifist. The argument is invalid, but one might still wonder whether we can nonetheless construct a derivation proving it is in fact valid. If we could do that, then our derivation system would be inconsistent and useless, so let's hope we cannot. Well, can we derive flaw from XFX? If we follow the pattern used above, first we write down the problem, then we solve it simply by applying the appropriate rule of inference. Following this pattern, the derivation goes as follows. 1 XFX PR2 flaw DD3 flaw 1, O. Wrong. This derivation is erroneous, because in line 3A is not a permitted substitution according to the O rule, because the letter used is not new, since O already appears in line 2. We are permitted to write down FB, FC, FD, or a host of other formulas, but none of these makes one bit of progress toward showing flaw. That is good, because flaw does not follow from the premise. Thus, in spite of the notation, O is quite different from the other rules. When we apply O to an existential formula, say, XFX, to obtain a formula, say, FC, we are not inferring or deducing FC from XFX. After all, this is not a valid inference. Rather, we are writing down an assumption. Some assumptions are permitted and some are not. This is an example of a permitted assumption provided, of course, the name is new, just like assuming the antecedent in conditional derivation,